Hi, this is Mrs. Rodriguez, and this is a video review for the Chapter 3 test that's coming up for you guys. This is a practice test that can be found on page 207 of your textbook. So I'm just going to go over some of the problems that I think will be helpful to you on the coming up exam. Okay. All right, here we go. I'm going to just share my screen with you. Okay, so like I said, this is a practice test, and it is on page 207 of your textbook if you want to follow along. And remember, I'm just going over some of the problems, not all of them. Some of them are the same type. Okay? All right, so first problem is a kind of a word problem. It says the equation to convert Celsius temperature C to Kelvin temperature K is shown. Okay, here's the equation here. K equals C plus 273. And it says here to state the independent and dependent variables and to explain. Okay, so the independent variable is going to be Celsius. Okay, remember your independent variable is on the x-axis. Okay, so if we look at our x-axis, there's the C. The C, it told us, is the Celsius temperature. Okay, so the dependent variable is on your y-axis, which is K. That's going to be Kelvin temperature. Okay, so the Kelvin says to explain. So the Kelvin temperature depends on the Celsius temperature. Okay. All right, that's part A. And then part B says determine the C and K intercepts and describe what the intercepts mean in this. Okay, so the C intercept, okay, it crosses here at C, right here at negative 273, 0. Okay, so that means negative 273 degrees is equal to 0 degrees Kelvin. Okay, so negative 273 degrees Celsius is equal to 0 degrees Kelvin. Okay, and then the K-intercept right here is 0, 273. So that means when the Celsius temperature, when it's 0 degrees Celsius, it's 273 degrees Kelvin. Okay, or when it's 273 degrees Kelvin, it's 0 degrees Celsius. Okay. All right, let's look at the next problem. Okay, so problem number 3, it says to graph each equation. Okay, now I'm looking at this equation and I see that it's in slope-intercept form, right? So it might be thinking, well, there's no y-intercept. Well, plus 0, right? Plus nothing. Okay, so our y-intercept is going to be 0. That means it crosses the y-axis. Remember, this is x, this is y. The y-axis at 0. So it crosses it here at the origin. Okay, and then the slope, because it's in slope-intercept form, is 4, okay, or 4 over 1, so you can draw your line, right? The rise is 4, the run is 1, so we go up 1, 2, 3, 4, over 1, and put a line there, up 4, over 1. We could also go down 4, and to the left 1, down 4, and to the left 1, okay? And we can draw our line there. I'll try, so hard to draw lines. Okay, I did my best, but you can obviously do it better on your paper, okay? Or on the test, they'll be there, and you just pick one, okay? All right, so what about number 5? Number 5 is not in slope-intercept form, but we can rewrite it in slope-intercept form. So first thing I would do is add y to both sides. So I have y minus 3x is equal to 5. Got rid of that y on this side. And then what I would do is I would add 3x to both sides. And now I have y by itself. I have 3x over here plus 5. Now it's in slope-intercept form, right? So my y-intercept is equal to positive 5. So that means it crosses the y-axis at positive 5. And then my slope is equal to 3, or 3 over 1. So I go up 3 over 1, up 3 over 1, or I can go down 3 over 1, down 3 over 1, okay? Okay, and then I draw my line. Going through all those points, okay? All right, next problem. Problem 7, now it says to solve each equation by graphing, okay? Now, when it says to solve each equation by graphing, the solution is where the line crosses the x-axis, okay? So what I'm gonna do here is I see that the y-intercept is 6, right? Because it's in slope, well, I could rewrite it in slope-intercept form. I can make this negative 3x plus 6, okay? So my y-intercept is at positive 6, okay? And then my slope is negative 3, or negative 3 over 1. So that means my slope is going to go down 1, 2, 3, and to the right 1. Okay, down 3, to the right 1. Okay, or I could go up 3 and to the left 1. Okay. Okay, so, and then I can over here go down 3 and to the right 1. So I see that it crosses my x-axis at positive 2, okay? So the solution is x equals 2, okay? So you would start at the y-intercept and then use the slope to keep making points until you cross the x-axis, okay? And this one crosses at exactly 2, okay? I think I have one more of these. Yeah, solve each equation by graphing, okay? So I want to write this in slope-intercept form. So I'm going to subtract 4x from both sides. Oh, excuse me, now I want to okay, sorry about that. So let me share my screen with you again. Okay, so what I would first do here is subtract 12x from both sides, and I would get 0 equals negative 8x plus 16. So my y-intercept, oops, sorry, didn't click on share there. Okay, so I subtracted 12x from both sides, and so that left me with 0 equals negative 8x plus 16. So it's in slope-intercept form. So my y-intercept is equal to positive 16, and my slope is equal to -8, or -8 over 1. Okay, so because my y-intercept is 16, I'm going to make these go by 2. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, so my y-intercept is going to be right there. And then I'm going to go down 8 and to the right 1. So I'm going to go down, remember these are by 2, so 2, 4, 6, 8, and to the right 1, and then down 2, 4, 6, 8, and to the right 1. Okay, so notice it's going to cross my x-axis at +2. Okay, so that is my solution. Okay, x is equal to 2. All right, so just want to talk really quick about slope. Remember, slopes that go up from left to right, those are positive slopes. They're going down from left to right, that is a negative slope. If you have a horizontal line, that's a 0 slope, and then a vertical line is an undefined or no slope. Okay, so just keep that in mind. So you just have kind of like a visual of what the slope is. So it says here to find the slope of the line that passes through each pair of points. Now, this is, if you're finding the slope given 2 points, you're going to use that slope formula, that y2 minus y1 is equal to x2 minus x1. And I noticed a lot of you did that on your quiz. So this ends up being -2 minus -2 over 3 minus 5. So again, I'm going to add the opposite. So -2 plus the opposite of -2 is +2. And then 3 minus 5, that is -2. Now, -2 plus 2 is 0. And then we still have -2 as our denominator. Now 0 divided by -2 is 0. Okay, a lot of students made this mistake on the quiz. Okay, undefined is when there's a the 0 is in the denominator. Okay, but if the numerator is 0, 0 divided by any number is going to be 0. Okay, all right. So the slope is 0. So that means this line would look like this, okay? It'd be a horizontal line. Okay, so let's look at number 13. So we have, again, this y2 minus y1 over x2 minus x1. So then you fill in your numbers here. I would put 4 minus -3. And then x2 is going to be 6 minus 6. So here I would add the opposite. 4 plus the opposite of -3 is +3. 6 minus 6 is 0. Okay, so that's 7 over 0. And I just said on the previous slide, you cannot divide by 0. So if the denominator is 0, that means it is undefined or there is no slope. Okay, and that is a vertical line. Okay. All right, so let's look at number 14. It says, which is the slope of the linear function shown in the graph? Now, first thing you should notice about this graph, it's going to have a negative slope. It's going down from left to right. So immediately, I can eliminate C and D because those are both positive. Okay, A and B are negative. So now if you look at them, is the rise, we just had to figure out, is the rise 5 and the run 2, or is the rise 2 and the run 5? So you have to pick 2 points that are directly on the line. So it looks like this point here is directly on the line and this point here. So you have to see, okay, well, is it going, here we go down 2 spaces, and here we go 1, 2, 3, 4, over 5 spaces. So the rise is 2 and the run is 5. So it has to be B. This one is saying the rise is 5, so that would mean we go down 5 spaces and then over 2. Okay, so that one has to be -2/5, which is B. All right, then there's another section that discusses direct variation. So direct variation equations are of the form y equals k times x, and k is not equal to 0. Okay, all right, and it always passes, when you graph it, it always passes through the origin. Okay, so let's look at a couple of these. it says, suppose y varies directly as x. Write a direct variation equation that relates x and y, then solve, okay? So remember that direct variation equation is y equals k times x. So now we plug in the information it gave us. Okay, when y is equal to 6, x is equal to 9, okay? So it's 6 equals 9k. So we can divide both sides. We have a one-step equation, so we do the inverse, divide both sides by 9. So 2/3 equals k. All right, then it says to find x when y is equal to 12, okay? So we are using our direct variation equation, which is y equals 2/3 x, right? Remember, we just found out what k was. What's our variation, okay? So here's the equation y equals kx, the direct variation equation. Now we figured out k is 2/3. Okay, so there's our equation. Now we're plugging in 12 for y. So we have 12 equals 2/3 times x, and we are trying to figure out what x is. Okay, it says to find x. All right, so x is being multiplied by 2/3, so we're going to do the opposite, and we are going to divide both sides by 2/3. Okay, so I'm dividing 2/3 by 2/3. That's equal to x, and then 12, I'm dividing that by 2/3. And remember, when you're dividing fractions, you multiply by the reciprocal. So I can see that I can cross simplify here. So 2 goes into 2 once, and 2 goes into 12 6 times. So I multiply straight across. 6 times 3 is 18 over 1, which is just 18. Okay, so x is equal to 18. Okay, let's look at another one of those. Here now it tells us if y is equal to -5 when x is -2, what is y when x is equal to 14? Okay, so again, we have our direct variation equation. We know y is -5, and we know that k is -2. So this is -5 equals -2k. Divide both sides by -2. And we end up negative divided by negative is positive. So 5 over 2 is equal to k. So our direct variation equation is 5 over 2. Y equals 5 over 2 times x. Okay. Now we want to find y when x is 14. So we're looking for y, and we're going to substitute 14 in for x. Okay. So we're going to put that over 1 and multiply. I see I can cross simplify. 2 goes into 2 once, 2 goes into 14 7 times. So y equals 5 times 7, which is 35. 1 times 1 is 1. So y is equal to 35. Okay. All right. Number 19, word problem, everyone's favorite. The number of pints of blood in a human body varies directly with the person's weight. A person who weighs 120 pounds has about 8.4 pints of blood in his or her body. Write and graph an equation relating weight and amount of blood in a person's body. Okay, so remember again, our direct variation equation. So y is equal to k times x. Okay, so we end up with 8.4 is equal to k times 120. Okay, so 8.4 is equal to 120 times k. Oh. Okay, sorry about that. 120 times k. So we would divide both sides by 120, and we end up getting 700 equals k. So when we write our equation, y is equal to 700 times x, okay, or the weight, okay? So if it's asking, oh, here's our equation, okay? And then part B, I believe, asks you to solve it didn't come out on the slide, but it asked to solve for a 171-pound person, okay? How much blood is that person going to have? So we plug that information in to our equation. So we have y equals 7/100 Okay, sorry about that. This part B, I did have it. It says to predict the weight of a person whose body holds 12 pints of blood. Okay, so remember our equation was y equals 700 times x, and x is the weight and y is the amount of blood. So it's asking about 12 pints. So 12 is equal to 700 times x. So you would divide both sides of the equation by 700, and you end up getting 171 equals x. So that person is going to weigh 171 pounds if they have 12 pints of blood. Okay? All right, next section talks about arithmetic sequences. And an arithmetic sequence is a numerical pattern that increases, like this one here, or decreases at a constant rate. So notice each time it was at 2 was being added here, over here it was being subtracted by 4, okay? And that constant rate is called the common difference, okay? So let's look at a couple of those problems. So here it says to find the next 3 terms of each arithmetic sequence, okay? So this one, we add 3 from here to here, add 3 from here to here, and add 3 from here to here. So the next one, if we added 3 to 14, that would be 17. Add 3 to 17, that'd be 20. And add 3 to 20, and that would be 23. Just asked you to find the next 3 terms in each arithmetic sequence, okay? All right, number 22 says to determine whether each sequence is an arithmetic sequence. If it is, state the common difference, okay? So here, 8 is being added to each one of these terms, okay? So yes, it is an arithmetic sequence, and the common difference is positive 8, okay? Now, number 23, here, the difference is 75/100. Here, the difference is 1 5/10. Here, the difference is 3. Here, the difference is 6. So it's not a constant, there is no common difference. The difference is changing. So this is not an arithmetic sequence. Okay. All right. And then number 25 says, in each figure, only one side of each regular pentagon is shared with another pentagon. The length of each side is 1 centimeter. If the pattern continues, what is the perimeter of a figure that has 6 pentagons? Okay, so here I'll make a little table here. The figure number, and then the perimeter. It's asking about the perimeter, not the number of figures, okay? So in the first figure, the perimeter is 1, 2, 3, 4, 5, right? It's pentagon. Okay, now in the second figure, the perimeter is 1, 2, 3, 4, 5, 6, 7, 8. That is not part of the perimeter, okay? Perimeter, remember, is the distance around a figure, okay? So over here, if we count for the third figure, the perimeter is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so if we look here, we can see that the perimeter is increasing by 3. Okay, it's increasing by 3 each time. So if we were to write an equation for this, it would be 3x plus 2 equals y, or 3 times the figure number plus 2 is equal to the perimeter, which is y. So if we're asking about the perimeter of a figure that has 6 pentagons, we would put 6 into our equation plus 2, so that'd be 18 plus 2 equals y, which is 20. Now, if you're taking a test and you have a similar question and you can't come up with the equation, we'll just continue the pattern, okay? The fourth figure, if we add 3 to 11, that's going to give us 14. The fifth figure, we add 3 to 14, that's going to give us 17. The sixth figure, if we add 3, that's going to give us 20. Still going to get the same answer, okay? Which is H here. All right, so as long as you're, if you have a different way of coming up with the answer, that is perfectly okay. Just make sure you're showing all of your work on your test. It's extremely important. Remember, I mark the problems wrong, right or wrong, and if you miss any problems, I look for the scratch work for those specific problems to give you partial credit. So show any kind of work that you possibly can for the problems. Okay, guys? All right, well, thanks for watching. If you have any questions, please call, text, email me, or stop by my office hours. And you guys have a great day.